realizing the dream of molecularly targeted therapies for cystic fibrosis. Definition. What is cystic fibrosis? In people with CF, mutations in the cystic fibrosis transmembrane conductance regulator gene cause the CFTR protein to become dysfunctional. When the protein is not working correctly, it's able to help move chloride and compound of salt to the cell surface. Without the chloride to attract water to the cell surface, the mucus in various organs become thick and sticky.
Hi, and welcome to another episode of Demystifying Medicine. On today's episode, we will cover cystic fibrosis. We will be discussing the basic biological principles of cystic fibrosis, the organs affected, and the various treatment options for this disease. So what do you, a panda, or a neighbor's pet have in common? We're all made up of cells. The cells can be thought of as a subunit of life. Inside these cells are a set of instructions called DNA. DNA is made up of the bases adenine, guanine, cytosine, and thymine. You can think of these bases as instructions that code for genes in your body. For example, the DNA contains instructions for traits such as hair type, eye color, and height. When a nucleotide base is added, removed, or substituted, it is known as mutation. These mutations can change the DNA code, which may affect the traits that are expressed in your body. Now that we know the fundamental genetic
Applications in medicine. The results of a pair of phase 3 clinical trials in the journal is simultaneous publication in the Lancet document impressive benefits from triple drug therapy of persons with cystic fibrosis and at least one copy of the FIR CFTR mutation.
A patient with cystic fibrosis is susceptible to infections of the lungs. This is due to a mutation that affects a protein on the surface of lung cells. Many different mutations can cause cystic fibrosis, but all of them involve a transmembrane protein called CFTR that functions as a channel for chloride to move in and out of cells. In this case, CFTR is less able to transfer chloride ions out of the cell compared to the functioning protein in people without cystic fibrosis. The channel is, in effect, locked shut. This inability to transfer chloride ions.
Pros and cons. The journey of gene-based therapies for cystic fibrosis began when enthusiasm over the prospect of gene therapy. The drug development efforts were needed in hopes of restoring the function of protein affected by cystic fibrosis, the cystic fibrosis transmembrane conducted by later.
Cystic fibrosis, or CF, is the most common genetically inherited, life-shortening chronic illness affecting young Australians today. A baby is born with cystic fibrosis every 4 days. Around 3,000 people currently live with CF in Australia. And 1 in 25 people are carriers of the CF gene. Carriers of the CF gene do not have any symptoms of the condition, but maintain the possibility of having children with CF. Despite improvements to treatments for almost all patients, nothing allows these children to breathe normally. With an average yearly treatment cost of around $22,000, the annual cost to the Australian community is in the realm of $68 million. Although the average life expectancy of someone with CF is now 35, many do not live beyond their teens.
But there is hope. Everyone's body
Issue applied in Ecuador. Now, results for two phase 3 multi-center clinical trials showed the safety and efficacy of triple combination therapy elexacaftor de facto in back for the approximately 90% of patients with cystic fibrosis with either one of two copies of CFTR mutation.
When I was on rounds as a medical student, I met a patient with cystic fibrosis. And as we were discussing what was going on, that her disease is caused by a protein channel that's missing in the lining of her lung, she stopped me and said, "It sounds like you know exactly what's wrong, so why can't you fix it?" And I realized she's right. Why can't we fix it? So it can be easy to treat a disease sometimes caused by too much function, but it can be much harder if you're sick because you're missing something. So my lab is working on the idea of molecular prosthetics. That is, could we find small molecules that can do what the protein is supposed to be doing? In a sense, operating like a prosthesis on the molecular scale. We found what we think is a good candidate for a molecular prosthetic for cystic fibrosis. And the really exciting news is that it's a medicine that's already approved and available on the market. It's an ion channel forming molecule called amphotericin. Amphotericin is typically used to treat fungal infections, and it's been known for a long time to form ion channels. So we figured out a way to use the ion channel activity of amphotericin to hopefully help it treat people with cystic fibrosis. It's also possible to deliver amphotericin directly to the lung.
Conclusion. The pair of phase 3 multi-center clinical trials report now document the efficacy and safety of elexacaftor in triple combination therapy for patients with one or two copies of the CFTR mutation.
CFTR protein stands for cystic fibrosis transmembrane conductance regulator. It's a pore on the cell surfaces of many organs in the body, including the lungs, sinuses, pancreas, and the gut, that's responsible for the movement of salt and water on these cell surfaces. The cell surfaces need the salt and water to keep regular health and is a problem when not functional in cystic fibrosis. When it's not functional, we have a loss of normal function, and that results in several downstream problems, including reduced clearance of mucus and a lot of inflammation, which cause damage to organs in the body. The abnormal protein function is due to mutations in the genetic code, or the information which encodes proteins, known as DNA. When the DNA is faulty, it results in abnormalities of the protein function at various different levels. There's a wide range of work being done in the cystic fibrosis community to address the problem of faulty CFTR protein function. This ranges all the way from clinicians to basic science researchers who are looking at ways to understand the protein malfunction and researching new drug therapies which target various mutations which cause different problems of protein function. As you